Transportation example number 2. The Ronet Transportation Company expanded its shipping capacity by purchasing 90 trailer trucks. Each of its warehouses were given 30 trucks. The warehouses are in Charlotte, Memphis, and Louisville. The company makes shipments from each of these warehouses to the terminals in St. Louis, Atlanta, and New York. Each truck is capable of making one shipment per week. The terminal managers have indicated their capacity for extra shipments. St. Louis can accommodate 40 additional trucks, Atlanta 60, and New York 50. Okay, so here we have our 3 warehouses with their limited supply of trucks. Charlotte, Memphis, and Louisville all have 30, which is a total of 90. Okay, our terminals have limited capacity for additional trucks. St. Louis 40, Atlanta 60, New York 50 for a total of 150. Okay, here we have the cost for each route. From warehouse 1 to A, $1,800, 1 to B, $2,100, 1 to C, $1,600, 2A, $1,000, 2B, $700, 2C, $900, 3A, $1,400, 3B, $800, 3C, $2,200. Okay, so our decision variables acts as the number of trucks sent from warehouse to terminal. So we have 1 to A, 1 to B, 1 to C, 2A, 2B, 2C, 3A, 3B, 3C. Okay, acts as the number of trucks sent. Okay, here's our minimum cost. The cost $1,800x1A, $2,100x1B, $1,600x1C, $1,000x2A, $1,000x2B, $900x2C, $1,400x3A, $800x3B, $2,200x3C. Okay, we have 9 decision variables because each of the 3 terminals can go to each of the 3 warehouses can send trucks to each of the 3 terminals. So each warehouse, there's 3 warehouses times 3 terminals would be 9 routes. Since there are only 90 trucks and 150 capacity, the warehouses can send out all the trucks. So these will be equal. So they're going to send out all the trucks from warehouse 1, which would be 1 to A, 1 to B, and 1 to C. They're going to send out all 30. The same thing for warehouse 2. 2 to A, 2 to B, and 2 to C will all add up to the 30 trucks there. And warehouse 3 is going to also send out all 30 because there's 90 trucks and they have capacity for 150, so we can send out all 90. We're going to send out all 30 that are at 3. 3A, 3 to B, and 3 to C. Since there are not enough trucks, there's only 90 to meet the extra capacity of 150. The extra capacity will be less than or equal to, because 90 is less than 150, we don't have 150 trucks. So these have to be less than or equal to. So the total trucks received at Terminal A would be 1A plus 2A plus 3A, less than or equal to 40. The total received at Terminal B is less than or equal to 60. 1B plus 2B plus 3B, less than or equal to 60. And the total trucks received at Terminal C is less than or equal to 50. 1 to C, 2 to C, and 3 to C, less than or equal to 50. And of course, each x must be greater than or equal to 0. Okay, now we're going to go solve our model. I have everything typed in so we can see what all our constraints are. So we have our 9 decision variables. Our cost equation equals 1,800 times x1a plus 2100 times 1B plus 1600 times 1C plus 1000 times 2A plus 700 times 2B plus 900 times 2C plus 1400 times 3A plus 800 times 3B plus 2200 times 3C. Okay, now, these are the supplies. Okay, these are the supply for warehouse 1, 2, and 3. Okay, so supply for warehouse 1 equals 1A plus 1B plus 1C. And that's equal to 30. These three are all 30. For warehouse supply for warehouse 2 equals 2A plus 2B plus 2C. And we have equal to x3A plus 3B plus 3C. Okay, now we have terminals A, B, C. And we have less than or equal to 40, 60, 50. Okay, so the capacity for the terminals for terminal A is going to equal to 1A plus 2A plus 3A. Okay, that means all the stuff that goes to terminal A. The capacity for terminal B, okay, so they're starting off in the warehouse and ending up in the terminals. So that's 1B plus 2B plus 3B. Okay, everything that goes to terminal B. Okay, everything that goes to terminal C equals 1C, 2C, 3C. Okay, so they're starting at the warehouse and going to a terminal. So trucks could go from 1 to A, 1 to B, 1 to C. They could go from 2 to A, 2 to B, 2 to C. They can go from 3 to A, 3 to B, 3 to C. Okay, data, solver. Okay, our objective is in B19. This is cost, so click min. Our decision variables are B9 through 17. Okay. Our first three constraints are equal, so we can add. B1, 2, 3 equals to C1, 2, 3. The last ones are less than or equal to, so add. B4, 5, 6 less than or equal to C4, 5, and 6. We need to add that the decision variables are greater than or equal to 0. Okay. Solve. Okay. Okay. Now, this is the number of trucks, okay? We can't send part of a truck. So let's go back to Solver and let's change that our decision variables, let's make them integers. And click OK. Okay, so now we have whole numbers for all our integers. So we're not going to send stuff from every route. See how we have some zeros? So these are the routes that we're going to do. 1A, 1C, 2B, and 3B. And here's our minimum cost. And that's the end of that example.